how to define electromotive force. Energy needed to move charges around the circuit, meaning beyond just 2 points. Move the charge from point A to B to C to D if those are the 4 points I have in the circuit. But moving the charge from just point A to either point B or either point C or moving the charge just from a point to another point is what is known as potential difference. Both of them are measured in volts and they have the same formula. So this is a symbol. If you use this, that one is meant for electric field intensity. This is going to be work done, energy needed in moving what? Charge. Work done over what? Charge. So work done is measured in joule, charge is measured in coulomb. So which I can say unit for electromotive force or potential difference. They are the same. Just like this one, we are moving the charge beyond just 2 points. But in potential difference, we are moving the charge between just 2 points. They carry the same formula, they carry the same unit. So electromotive force is work done over charge because we are working to move what? Charge. So work done is measured in joule, charge is measured in what? Coulomb. So I can say the unit for electromotive force is joule per what? Coulomb. Or I say what? Volts. Potential difference as well is work done over what? Charge. So I can say the unit is joule per coulomb or volt. So that is about this. Now let's go to Kirchhoff's rules. There are 2 rules for Kirchhoff. This is one of the formula we may need. So work done over charge. So leave that one too. So let's go to this now. There are 2 laws for Kirchhoff. One of them is called current law. It's also called junction law. And the other one is called voltage law. It's also called loop law. Those are the names. And it's a very simple law. The one we call current law. If this is a junction in your room, you should know what a junction board is. There's one plastic plate you see the electrician, they put some wire inside, they cover it like that. That is what they call junction board. So the amount of current coming to the junction board must be the amount of current leaving the what? Junction board. That is the electric law of Kirchhoff. So I state it. Kirchhoff electric law states that the amount of current coming to the junction must be equal to the amount of current leaving the junction. So mathematically I can say the sum, this is sum of current in the junction, current in, must be equal to the sum of current what? Out. So this is mathematical representation of Kirchhoff current law. I repeat it again. Kirchhoff current law states that the amount of current in the junction must be the amount of current out of the junction. So when you on your generator, the amount of current coming from the generator entering this must be equal to the amount of current that is leaving this to your room. That is exactly what Kirchhoff. So you will note this. Sum of current in, summation of current in must be equal to summation of current out. That is called current law of Kirchhoff or junction law of Kirchhoff. Now on the other hand, we have the second Kirchhoff law, which is now a voltage law. We also call that one loop law. So the voltage law says that the sum of the change in voltage must be what? Equals to what? 0. I think I've been able to prove this one when I was talking about properties of equipotential. I told you that when electric potential remain constant, it means the change in the electric potential must be what? Equals to 0. That is what the Kirchhoff second law states. That the summation of the change in electric potential must be what? Equals to 0. Why? Because potential itself is what? Constant. When electric potential is constant, meaning there is no change in electric potential. That shows that the change in electric potential becomes 0. So how do you state this one in word? You say Kirchhoff voltage law states that the summation of the change in the electric potential, the summation of the change or the summation of the rate of change in electric potential must be equal to what? 0. And so this is the mathematical representation of it. Summation of change, this is delta V. Summation of change in potential must be equal to what? Must be equal to 0. That is the Kirchhoff second law, or Kirchhoff voltage law of electricity. And lastly, we shall be looking at RC. Now, I won't go deeply into this so that I'll be able to take one or two calculations. R stands for resistor. C stands for capacitor. So when you see RC, it means a circle that contains both resistor and capacitor. And at times you can see it as R, L, C. They can include A. It means this one is a circle that contains resistor, inductor, capacitor. This one is resistor and capacitor. This one is resistor, inductor, and capacitor. So when you have a circuit, when you have, okay, we are done with this, so I can do all the calculations somewhere here now. So when you have a circuit where resistor and capacitor are used, this is a symbol for a resistor, and this is a symbol for capacitor. When you have a circuit where both capacitor and resistor are used or are shown, it is called RC circuit. But when the three of them are shown, it is called RLC. Now, when the three of them are used, in this topic they shall be called impedance. Impedance, that is their name. But when only, okay, let's make it a little bit clearer. In a circuit where I have capacitor and inductor, or only capacitor, or only what? Inductor, it is called reactance. So the name is called reactance. So a reactance is the opposition offered to the flow of AC current, because all this one is under AC. I take it again. A reactance is the opposition. What's the meaning of opposition? Regulation of AC current. But that regulation is offered by only what? Capacitor, or only what? Inductor, or is offered by both. It shows that reactance is of two types. If the opposition is offered by only the capacitor, it shall be called capacitive reactance. Capacitive reactance. Now, if the opposition is offered by inductor only, it is called inductive reactance. Now, but the term is called reactance. So, by definition, a reactance is the regulation that is offered to an AC circuit, and that regulation must be offered by either a capacitor or an inductor or both. We continue in the next class.